So, welcome back guys, my name is Parker and welcome to ParkerPrograms. Today we're going to be tackling problem 6 of Project Euler, which is that the sum of the squares of the first 10 natural numbers is blah 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 385. The square of the sums of the first 10 natural numbers is blah blah blah, which is 55 to the power of 2, which is 3025. Hence, the difference between the sum of the squares of the first 10 natural numbers and the square of the sum is 3025 minus 385, which is 2640. Find the difference between the sum of the squares of the first 100 natural numbers and the square of the sum. Okay, so let's jump over. Same thing as always, we are going to create a new, I've lost it again, there we go, a new item, which I'm just going to call... Should we just call it... Oh god, I just called it class 2. Oops. This is what happens when you joyously hit the wrong part of the keyboard. Let's just quickly... Square sums. And over here, and... would you like from arena? Yes. Great. Okay, perfect. That solved my issue. So, once again, we are going to go a... public... static... void... execute... just going to give us something to work with outside of here, inside of program. We can just comment this one out. This is the old one. And we'll just get it ready up here. So we have got square sum, that's the one. Square sums dot execute. So next time you run this program, this one should just work perfectly fine. Okay. So, if we head back, it was that we needed to figure out the sum of all the individual squares. Okay, so we need the sum of the individual squares. And the other one was that we needed the square of the individual sums. Okay, so what I'm going to do is I'm going to create a couple of functions. So, this will return an integer. So, by default, this is going to be private integer, which we're going to call individual square sums. And we're going to do the exact same private integer square individual sums. There's probably some better names for this, but, you know, for both of these, we're going to take it an integer, which is going to be called, well, let's do minval, and another integer called maxval. And we'll just do this for both of them. That way we can easily swap this in and out as we see fit. I mean, I know for this demonstration purposes, we're going to be doing it from 1 to 100, but as with the previous episode, we're going to use the answer that we already know we have to check that this is actually working. Okay, so what we're going to do is we're just going to do a for loop for int I is equal to minval. I is less than or equal to maxval. I plus plus. We are going to have an integer, which is total, which is equal to 0 by default. And we're just going to keep adding to this number. So, for each value in this, total plus equals the I times I. So, that's going to give us the total when we hit the max value. Everything should be done, and then we can just return total. Like so. Admittedly, this might just return 0 if there's no range, which could be wrong. If minimum value is, say, 7, and maximum value is 7. Actually, wait, no, that would still work, because this is equals to, so it will still run through this at least once. Okay, cool. So, moving on to the next one. Again, we're going to have int total equals 0. At the end, we are going to return this total. Just try and keep things uniform. So, we need to get the sum of all of the individual ones and then square it. So for int I equals min val, I is less than or equal to max val, I plus plus, we are just going to add total plus equals I. So this is just going to add all the totals to get the values together, and then we can just do total times equals itself, like so. And that's going to return the square of the individual sums. Okay, so we've got these two done. So now, we've got the sum of the individual squares, which is this one, and the square of the individual sums, which is this one. Bingo. Okay, so now we just need to actually punch in the numbers to ensure that we have what we know we have. So, is there anything we can say? Can we guarantee that one is going to be higher than the other? Let's see. 1 plus 2, we got 3, 9. Okay, so basically we can usually guarantee that it's going to be above, that the square of the individual sums is going to be higher. No, sorry, yeah, the square of the individual sums is going to be higher than the individual squares. Okay, so what that means is that we are going to just go integer. Final val is equal to, and it's going to be the square individual sums, and I know Wireless is complaining, and we're just going to do 1 to 10, which is the value we have, and it's complaining because these aren't also static. That should fix this now. Does not exist in the current context. That's why, square individual sums. And then we are going to minus the individual square sums between those same values of 1 and 10. So I believe that's, so natural 10 numbers, blah blah blah. Yeah, so it's 1 to 10 here. So running this, we should get an answer of 2,640. Once I quickly just write this out outside the final val. So let's run this, and we get once it finishes building, and we get 2,640, which is completely, there we go, 2,640. So we know this is actually working, in which case we can just stop it. So now we just need to change this from 1 to 100. And this is sort of part of the joys of being able to make your code sort of just transferable and interchangeable like this, is that, you know, these changes are easy and simple to make. I need to see, we could even pass in the values into execute here, but for our purposes, just because we're solving this one problem, that's not an issue. If this was for a larger system or a larger program, that's exactly what I would be doing, is I would be putting the minimum value and the maximum value into here, and then the values from here would be passed across into these. But anyway, so let's give this a run and see where this gets us. And we have, oh god, that's a large number, 25164,150. Okay, cool. So let's just pull this to one side. We will jump back over to Project Euler, and we will type this in. So it's 25164,150. Confirmation code is 81209. Let's check this. And we've got the correct answer. That was yeah, I like that. That was a nice and easy one. Okay, let's have a look at the next one, shall we? And see how bad that one is. So we've just completed this one. By listing the first 6 prime numbers, we could see that the 6th prime number is 13. What is the... Okay, right. The 10,003rd prime number. Now, this one is a bit of a pain in the backside because I've tried calculating prime numbers before. So I'm going to skip this one and probably come back to it, because I've tried doing this before for one of the previous questions, which was the largest prime factor. But calculating the prime numbers up to that value takes a long time. So I'm not going to actually do that. I will probably come back to these and do these at some point. It's just at the minute I don't have enough time to leave my computer running, just purely calculating prime numbers. I might be able to get a different machine to do it, and if I'm able to do that, then fantastic, and I will get back to you guys. Otherwise, anything to do with primes I'm going to have to, unfortunately, ignore. So let's have a look at a largest product in a series. 4 adjacent digits in the 1000 digit number that you have the greatest product for are 9. 9 times 8 times 9 equals this. Okay. Find the 13 adjacent digits in the 1000 digit number that have the greatest product. What is the value of this product? I mean, I think this one's possible, but I don't think I'm going to be able to get it done in this time scale. So I'll actually leave this question for next one. I mean, you guys have seen the next problem, so if you want to go away and give it a shot yourself, you're more than welcome to. But anyway, I'll see you guys in the next video, when I am going to be checking this one out and trying to find the best possible number that I can. So, thank you guys so much for watching, and I will see you guys in the next video. Bye.